I'm Tim Ventura from AmericanAntiGravity.com, and I'm speaking today with Warren York, who's had some very interesting results from recent time displacement and unified field theory experimentation that he's been conducting along with Mike Windell and a few colleagues. Well, Warren, thanks for joining us, and I guess I should start out with kind of the overview level stuff. I have a ton of materials that you sent me. A lot of that are photographs of what look like beam devices. It looks like they're like maybe almost like a large neon coil on its end, but it has ripples of light through it. I was wondering if you could tell us a little bit about what's in these photos.
Yes, the original experiment, Tim, was back in 1998 in Texas. And we weren't really trying to set out to do anything particularly. However, in the process, we had a very unusual event take place. At that time, what we were doing is we were modifying electromagnetic fields and trying to generate what were called at that time plasmoids. Now, unbeknownst to us, meaning Mike Windell and myself, and it's also Charlotte Geier, who's part of the team, there is an actual phenomena in physics called plasmoids. We thought we coined the word, but unfortunately it's already coined. A friend of mine, Dr. Mead at Phillips Laboratory at Edwards, had sent me the test reports on plasmoids. But get to the point, is that in this process of trying to generate plasmoids, because we had the idea from the unified theory that we needed to find some kind of process that would couple to the time continuum. In other words, this is the basics. Well, how do you make a time device?
Sure.
Instead of just being Star Trek-ish, with something that doesn't really have anything tangible, we were looking for something tangible that would say that it is possible. Well, way before this experiment, I spent a whole summer studying nature, mainly lightning storms, because I had an observation. And I conveyed this information to Mike. Now, as you know, and I hope I don't digress too far back for you, but my physics professor in college was from China, and he told me if you ever have a problem in physics, to look at nature for the answer.
Yeah.
So mankind in the past knew he could fly because nature told him he could by watching the birds. And it took him a while, but he finally figured out the process, and you see where we're at today as far as aviation goes. Well, I posed the same question to nature. Where in nature does it show a probability that time is an actual engineerable concept? And I found several places, believe it or not. One place, which is a little bit harder to understand, and I didn't send you those pictures, by the way. I don't think I did, is in lightning storms. But because that gets kind of involved, I'll go to the quicker and the shorter method that anybody could do a Google search on and find out for themselves. But nature actually does time jumps every single day.
Okay.
At the quantum level. And if you want to look into this, you look into a subject called tunnel dioding.
Yeah, actually, another area for that, Tom Bearden has written about negentropic processes. I believe that's how it's pronounced. Time reverse processes on a small scale, I guess.
Tom is a pretty good friend of mine. In fact, he walked into the garage there at Huntsville, Alabama when I first met him. This is before he coined his scalar wave technology. And basically, we set off at that point. Tom went one way. He is an engineer, by the way, and I went a different way. Basically, at that time in Huntsville, Alabama, I was studying phenomena, all of phenomena. But I didn't have anything at that point that was tangible. I didn't have anything until many years later that was actually tangible, that was replicatable.
Well,
that had to do with a completely different field, but it did lead us into this time dilation process.
Let me briefly describe for the audience what I'm seeing in these photos, because these are absolutely amazing. Speaking of which, I should really compliment you guys on some wonderful photos. I mean, you guys are shooting in low light conditions, and so it's difficult to begin with, for most cameras. But I mean, not only are they beautiful photos, but they capture the intricacies of some really unique effects. Now, obviously, as they're still photos, I'm not seeing anything that jumps out at me as being time displacement. But what I am seeing, as someone who's worked a fair amount with neon and related technologies in the past, basically, you have kind of hockey puck shaped anode and cathode, right, separated inside of an evacuated glass cylinder. And
Correct.
it looks like they're maybe, they look like maybe 2 to 3 feet apart, I guess. But the part that amazes me, again, as someone who's seen a lot of neon, neon typically is neon. You have a glow that goes between the anode and the cathode, and it's pretty, but it's not very remarkable. But in this particular case, in the cylinder photos you have, to begin with, the glow has striations in it, which is just amazing. I've never seen that before. And the striations are, well, they're around different parts of the anode and the cathode, but they also occur at different points, almost like stripes within the neon glow itself. If you can imagine horizontal stripes running down a column of glow. And that's something I've never seen before. And to be honest, it looks almost as if those are scalar fields of intensity.
What those actually are is you're looking at a standing wave phenomenon, which is very rare.
Sure. I guess
Now,
that would be scalar, do you think, in nature, or would it be something?
Yes, they are scalar in nature, but they're a little bit more complex than just calling them scalar. What led us into that, what you're looking at there are the refined test equipment. Our original one on the original video you have is very crude, and all you actually see is a neon tube and a incandescent filament vibrating from the inner reaction of the magnetic field. Now, that particular video is the original video, and if you just look at it and you watch the ending of it, you're not going to see anything that's going to grab you or that's going to say anything unusual happened. But let me digress a little bit for the people that do view that video. That original video, the first one where it showed the tube and the filament being stuck to the lab.
Yeah. If I could set that up a little bit for you. This is something that we had talked about earlier, and I sincerely appreciate your sending it over. We've been waiting a while on this story, and it's exciting to finally get it out there. I saw at the very end of the video a telephone line repairman, which you had told me about. And I guess the timing that was involved with that was really the tip-off that time displacement occurred, right?
Right. The timing on the video does not match the real time of the event. That's not all that doesn't match. On the video, you hear us laughing because the lineman is on the pole scratching his head saying we're the only people in the area that has power. Now, Mike and I could look out across the field and it was lit up. There's lights everywhere. But when you look at the video, you won't see a single light.
Yeah, and
so
now
the video was seeing what the lineman was seeing, not what we physically were seeing.
Now, if I'm getting it correct, you went into the lab and you started testing with the apparatus. And we have some photos of the apparatus itself, and it looks like it's a combination of signal generation and high voltage equipment. And you were doing testing with the equipment, basically. And right. Now, from your perspective, a few minutes had gone by, but when you walked outside, it was several hours later. Is that accurate?
Correct. It felt like maybe 35, 45 minutes had gone by, but in all honesty, actually several hours had gone by. We went in the lab about 5 o'clock, about 4:30, around 5. I thought we were coming out around 7 or 8. It actually was 10, almost 11 o'clock when we came out of the lab.
Well, out of curiosity, one thing I should ask about, is the lab completely enclosed? Would you be able to see something like the sun setting outside, or?
No, it had no windows in it.
Okay.
It was totally enclosure.
So you were expecting to walk out then and see light, and instead you walked out and it was pitch black.
Well, we're fixing to shut down for the day because we had broken the experiment for that evening, kind of tinkering around. And the only thing we had noticed was a tremendous amount of energy was used somewhere, but we had nothing that actually burned up. And, this was curious, but we didn't think anything spectacular had taken place. And as we opened the lab door, here's this lineman going clunk, clunk, clunk across the backyard. It's dark out. And we filmed him climbing the pole and up on the pole. And this is what he said, that we were the only ones that had lights, and we thought that was funny, so we laughed about it. And that part's in the video if you listen. However, we still were not aware of anything greatly unusual taking place. We had no idea at that time yet about some kind of distortion occurring, because we didn't have any clue. We thought the lineman was pulling our leg. The next day, Charlotte Geier, who was also present during the experiment, and that's the second video you'll see, where she documents the events that took place that night, was wearing jewelry, topaz rings, and I think she had 2 topaz rings, or she had an amethyst ring and a topaz ring. She did not wear the pendant. The pendant is the control item that was left back at her house.
Okay.
She called me the next morning, and she told me that her rings that she had on, the topaz one and the amethyst one, had turned clear.
Now, how close was Charlotte to the equipment when this had happened?
She was about 12 to 40 feet away, varying the time during the experiment.
Oh, okay.
12 was about the closest she was. I was right up on target, and so was Mike.
Now, did you notice any other effects that would be time displacement effects? I mean, it would be difficult to guess, but light bending strangely, or maybe a Doppler shift. Did the lights, and this maybe wouldn't even be an indicator.
The behavior of the filament was strange, but it didn't key us into any strange time effects. But the way it was behaving, in fact, at one point, which is almost impossible to prove, the filament actually went through the glass on the outside and came back in.
Okay.
But that's too extreme to try to throw out to the public, plus the thing broke and we had no way of proving that afterwards other than the video we had taken.
It almost sounds like the Hutchison effect, where you have materials melting into each other in a way.
Exactly. Extremely. We didn't really put too much emphasis on anything really unusual happening until Charlotte called about her rings changing coloration. Now, this is the important part of that video, because that is the real meat of the event. We took the rings to the geology lab there at the university, UTEP, to try to get them to analyze what may have happened. And they came up with the conclusion that in order for the orbits of the electrons in the gems to have changed position, one of 3 things would have had to happen: extreme heat, extreme gamma ray, or extreme X-ray, of which any one of those 3 would have killed all of us in the room.
Sure.
To the amounts that were needed to do that.
Well, and it makes sense. I mean, crystals are hard. These are, the molecular structure there is set. And to be able to change something that's that locked in, those kind of hard and fast chemical bonds, would cause enormous damage to the human body. Plus, this also goes to the comparison with the Hutchison effect. It sounds like you're using similar equipment, right? The high voltage alternating current, right? Almost Tesla-ish equipment. And then
high frequency, yes.
Yeah, these are also very, I would say different, but Hutchison noticed molecular changes also. And in his case, it was difficult to say what had happened other than when they analyzed the samples after the fact, the molecular structure is different.
Well, what led us into this is I was communicating with Hutchinson at that time to set up our experiment, because I was aware that Hutchinson was into something, and it kind of fit my theory at that time, but my theory had not been completely congealed yet. It was still in the process of, being developed.
Sure.
And he was at Los Alamos Labs at that time with the Army, and they were testing his work at that time.
Okay.
And we had a nice conversation. In fact, he sent me a pile of his work, which is really outstanding if you ever look at the work that, he's been doing. But he, frankly, is very open about it. He'll tell you, as he's told me, I'm sure, that he didn't know what he did. He just knew if he did something like manipulated the fields or whatever long enough, something happened.
Yeah.
And of course, I conferred this information with Tom Bearden at the time, and this is where he was congealing his scalar field theory, and his approach was that it was an interference pattern, basically a scalar interreaction of what was going on, which is possibly very true. Tom is not incorrect in his thinking. But to get back to the fact, the crystals is really a very unique video because to change the coloration, it just can't be done that way.
Yeah, no, that makes perfect sense.
And the pennant you'll see is still smoke gray where you can't see through it. So it's the original color that the other topaz ring was.
Okay.
But most rings, the rings were involved in the experiment, are a slight yellow but almost clear, almost solid, which you'll see very good in the video. If you run it toward the end, there's a section where I did close-ups of the actual ring.
So that really covers both of the videos that we'll be putting up then. Again, the first one really shows the tube and the filament in kind of that resonant mode. And then the second shows, it's actually an interview with Charlotte Geiger that you filmed. And you really...
At the end of the first one, where the man's on the line pole, was a key to us as something was unusual because of the lights not being visible in the video when we physically were there and we physically saw them.
Sure.
But we can't prove that to you or anybody else. All you can see is what's on the video.
Yeah. Okay. Well, now in terms of the unified field theory itself, I mean, you have these anomalies that you're working with, and I think that a lot of these came out of a theory that you were developing at the time, right? And so you've got some notions in your mind about how you're progressing theoretically speaking, and then you start to see these results, and you plug those back into the theory. Can you tell us a little bit about some of the insights you've made about nature as a result?
Well, one of the first things we've noticed is that crystals are unique, but not magical, okay? In other words, there's nothing new age about this. This is strictly down-to-earth physics. The unique factor about crystals is they will maintain an optical holographic pattern, just like a recording tape will retain an audio distortion signal, or et cetera, et cetera.
Sure.
And the unique thing about that is we can encrypt, meaning we can encrypt any kind of a pattern within the crystal, and it will maintain that image unless we do something else to the crystal. We found out that if we put a state of dilation, which is part of the theory, this is not accepted out there, and it's not something I'm trying to push on anybody, but I believe the spookiness from the theory, from what I've seen so far, that when you talk about physical world and you talk about the quantum world, you talk about physical math and you talk about quantum math, as you know, and everybody else knows by this time, they don't add up. There's something wrong. It just falls apart at the quantum level.
Yeah.
I have come to the conclusion, and we're in the process of trying to prove this out also, that the reason why they don't make sense, or they're called spooky, and Einstein gave it that name, by the way, is because dilated states are taking place.
Oh, okay. In other words, you're changing time as a dimension, and to the rest of the world, which remains in a constant flow of time, it would just look like something is spontaneously jumping or happening or maybe even moving backwards, right?
Right. It's operating at a different time rate, a different ratio. And
Sure.
Everything is based on the speed of light, by the way.
Yeah, well, and it is interesting because time is always considered to be one of those unchanging fundamentals, despite the fact that Einstein himself said, it changes in relation to your frame of reference. So I think it's almost kind of a scientific double take that's been done in the past. When the basic formulas were laid down, time was assumed to remain constant, and then, as science progressed around it, nobody really stopped to look for violations of that, or maybe cases where it wouldn't apply in the same way, other than the really small scale stuff that relativity predicts.
Well, once again, let's look back at nature. Where does nature show us that there's possibly multiple time ratios? You could call it that, or you can call it dimensions. It doesn't matter. Now, theoretically, everybody says, yes, it's possible to have multiple dimensions within dimensions. Mathematically, it says it's possible. But where in nature do we see evidence that it actually could be occurring? There's been studies done on frogs and birds, etc. You ever consider a frog will catch a fly that's going by that we can't even see, but yet he has no problem in catching it in midair?
Sure.
His time rate perception is different than ours. To him, it may be going along like 3 miles an hour. It's no problem for him to get that target.
Yeah, yeah.
So that's a possible, I'm not saying it's conclusive proof, but that's a possible area in nature saying, yes, there is multiple time dimensions or multiple time rates that can occur all within one single time frame.
Well,
the other part in nature is actually the spin of an electron. Now, these are things you can look up. These are not theory. These are not something that I'm just pulling off the top of my head.
Okay.
Now, I know you probably don't know a lot about physics, but to make it very simple, in quantum physics and in physics is a thing called particle spin. That means how many revolutions is a particle rotating?
Yeah.
For our rotation at this physical level, if we turn a ball around, we can turn it 360 degrees before it reaches its starting point and starts all over again.
Okay.
Now, we can't physically see the electron, but we can measure it. It's a magnetic moment, which is the same thing as its rotation or its spin by its magnetic moment. We can do this electronically. That's how it's measured. You measure the electron's magnetic moment. When we measure it, it shows to be spin 1/2 for the electron, which converts out to be 720 degrees of rotation for every single 360-degree rotation we have. Now, that's impossible, but that's another spooky part of quantum physics. It's a known fact that is what's happening.
Now, you're suggesting then that the time dilation is what lets it do this by maybe dragging space along with it, or?
It's all relative. We're viewing the monitoring of that physical electron rotating through electromagnetics, through the magnetic moment. It physically, and from our time frame, is being observed as going 720 degrees rotation. In reality, if we could jump down onto that electron, we would only have turned 360 degrees for one rotation, but if we look back up at the physical world, it would only have turned 1/2 that.
Okay.
So its time rate is different. Now, there's physical evidence out there that this has actually been done. We have time travelers, if you want to look at it from a physical, scientific point of view. We have astronauts. It's a known fact. They've been in orbit, they've gone around in orbit, and they've lost microseconds.
Yeah.
That they'll never gain back. They are microseconds less than they would have been if they stayed here on Earth. Now, if you watch their watch and they're going around in orbit, they didn't see any loss of time. Just like the electron. They don't see any change in time.
Sure.
It's all relative. So the whole key to creating warp technology, and this is another thing that's in the theory, and it's not in any physics books, there's a thing called the distance of the speed of light. Now, when I say the speed of light and the distance of the speed of light, you will say they're synonymous, but they're really not.
Okay.
The speed of light is based on the constant, 186,000 miles per second per second. Okay, that's the time frame. If you change that ratio, you change the distance. It still is traveling, if you're with that electron or that photon, you're still traveling 186,000 miles per second. But it's dilated from the observation of the static point of view, which really is not static, but for reference sake, let's just say the higher up level that we started at, the physical level, is a static point of view.
Sure.
So it is, whenever you have a time shift like that, you will have dilation. Whenever you have a size or spatial shift, you will have dilation. That's why I use the word dilation.
Yeah, yeah. Now, the equipment that you're using, though, can create that in a static environment as well, and that's interesting. That's very different than I think what Einstein had talked about in terms of, the faster you move, the more dilation you have, or the higher the gravity field, the more dilation you have. In your case, you're doing something maybe similar in some ways to what Hutchison had played with, that you seem to have these dilation effects with, but it's
Really, it's
static,
the same
right?
thing. It's really the same thing that Einstein stated. And whenever you're talking about time, whenever you mess with time, you're messing with gravity.
Okay.
There's a direct connection.
Yeah, yeah.
So whenever you play with gravity, you're going to play with time. Whenever you play with time, you're going to play with gravity. So now we have a physical concept of how can we actually achieve such phenomena in the lab. And this is basically what we're at this point. We don't have all the answers, don't get us wrong. But we have phenomena occurring, and it's almost to prediction of the theory to this point.
Well, let me actually play off that for a moment and ask, now, in terms of moving experiments forward, I know that one of the areas, well, actually, I guess I should ask about this. Are you guys seeking funding? And if so, what kinds of experiments would you put that into in terms of moving this research forward and maybe doing more profound experiments in the future?
Well, we actually did receive funding today from what I have been gathered, and it's an extreme amount of money. But I'm not in a position right now to release any of that information until all parties have, agreed to what we need to agree upon.
Oh, okay. So it's already in the works then. You guys are already working on new ideas and moving it forward to that next step.
Yes, we're not throwing out other funding because, as I said, I don't know if the deal has actually been locked down yet or not. I understand that it's still in the making, but it's been a long time coming, and in this time and age, the funding is just about non-existent out there.
Yeah, it's definitely, I would certainly agree, it's difficult. But now, in terms of the theory itself, can you give us the website link so that the audience can visit and hopefully read about the theory online?
Yes, the easiest way to it, and you can ignore my business website, but I have it up there as a front door right now, and keep in mind, I do all my own web work, and I've had to take the page up and down 3 times because companies buy out other companies because all the addresses keep changing on me.
Sure.
So it's not a complete website like it used to be, and there's still some errors in there. But as I get time, I go in there and I work on it, I update it, and I put a new update on the articles that I've changed to keep anybody constant or up to date. So if they say, oh, I already have that article, they can look at the date and see if maybe I've added something new or altered something. But there is what I call, before the theory came out and the book was published, I used to call my theory the final theory. But there is an actual book released now called The Final Theory. And since it's already been published and released, and mine's still a draft format because it's still ongoing, if you put out a unified field theory, you have to address almost everything.
Yeah.
You can't ignore something. And the theory I've read from the final theory at this point is just an idea. It doesn't really have any meat to it that you can walk into the laboratory and try it out. Our theory has that. You can take parts of our theory, walk into the lab, and run your own tests and come to your own conclusions. You don't have to accept what I'm saying. So that's why I'm at. But I have a lot more work to go. In my theory, you'll find third-party work that were unaware of what I was doing, and their test results match my theory up 100%.
Oh, okay. Okay.
When you look at things called surface electron imaging, we did that on the electron. Our electron, by the way, we call it the YGEM, standing short for York-Geier Electron Model. That's where Charlotte comes in.
Oh, okay.
She did the theoretical work with me on that actual electron, and all that electron is our model of the electron. Why is it different than the regular model of electron? Because the regular model of electron is considered a prime particle. It can't go any lower. Ours goes lower. Ours is based on light.
Yeah. Now again, your website URL was
To get to the website, let me take you to the short one because people won't remember the real long one. The short one is simply ebook pubmaster, that's one whole word, dot W as in whiskey, S as in Sierra.
Okay, so it's ebook pubmaster.ws.
Right, ebook pubmaster.ws. Now, when you come to that page, you'll notice in blue, 4D for science, whatever, and you'll see one that says research. Those are links to websites. The one that says research is a link to my website. So click on the research. Don't worry about the business deal there. That's for, people that want to get involved in money aspects.
Sure.
I put that up there because I was looking for funding to continue the research, and we're just going to have to shut down. Hopefully, it's in the bag at this point.
Well,
but
that's
we're not
awesome.
going to throw anything out.
Yeah, that's awesome to hear that you guys are moving forward with things. Well, Warren, we're just about out of time for today, but I wanted to say thank you yet again for the wonderful photos. And we're going to also work up a written interview with yourself and or Mike and see if we can put some of the photos in there to help the audience get a better feel for kind of what the look and feel of this device is. But I wanted to say thanks again for the interview and for sending all this wonderful info out to us, and that the videos will be online soon as well.
Okay, let me add one more thing to people that go to my website. If you click on the yellow booklet for the final theory, it'll bring up the actual PDF file where you can read the book, which is ongoing, and I keep it updated. I also will be adding some papers because I've developed a math aid that I call 4D Unified Math. So if there's people that are math inclined, you may want to look at that because it's a very unique process. But, if you click on the icons, it's all self-explanatory. As long as you have a PDF reader, you should bring up the papers and should be able to read them in. I recommend anybody that wants to, feel free to contact me through my email address, and I'd be more than happy to answer any questions.
Great. Well, thanks again, Warren. Have a nice evening.
You too, sir.